everybody, and welcome to the Reuse Company webinars. My name is Cecilia Carlson, and I will be hosting today's webinar. With us today, we have my colleague, Jose Fuentes, and he will talk about the INCOSE guide for writing requirements and show us how to do a real-time quality assessment of the INCOSE rules. If you have any questions or comments during the webinar, you can use the chat box, but please address your comments to the Reuse Company and not to Jose Fuentes. The webinar will be recorded, and in a few days we will send you the link to the recording. This is the agenda of the webinar. First, we will have a description of the company and the presenter. Then Jose will talk about the INCOSE guide for writing requirements. He will show us how to do the mapping of the INCOSE rules into an Ontology library. After that, he will show us the systems engineering suite. Finally, there is a live demonstration, and after the presentation, we will have some time for questions and answers. Now let me say some words about the Reuse Company. Our mission is to a knowledge-centric approach to leverage system engineering activities for our customers. The Reuse Company was created in 1999 as a spin-off from University in Madrid by system and software engineers. Our headquarters is in Madrid, but we will also have offices in London and in Stockholm. Since the company is a spin-off, third University of Madrid, research and innovation is in our DNA, and about 10% of our revenues are dedicated to research and development. The Reuse Company is actively involved in several large European research projects. The Reuse Company is also called a TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C or almost Q like in quality. So who is using our technology? Here you can see some companies that are users of our system. They come from quite different industries like aerospace and defense, energy, automation, and healthcare, but also from other industries. Now let me introduce you to the presenter, Jose Fuentes. He's operating officer at the Reuse Company, and he has been the product manager of the systems engineering suite tools for more than 5 years. He has the INCOSE CSEP certification and is a member of the board of the Spanish chapter of INCOSE. He's also an active contributor to the INCOSE guide for writing requirements. So let's start then with the presentation. We hope this topic will be interesting for you.
So, good morning, everybody, or good afternoon, good evening, and welcome to this webinar on this interesting topic of how to map the rules in the INCOSE guide for writing requirements into a tool that can automatize the inspection process of your document, and at the same time can help the engineers in the activity, demanding activity of writing new requirements following this guide. So first of all, let me some few words about what INCOSE is. Probably you all know about INCOSE. INCOSE is the International Council on Systems Engineering, and the aim of this council is to develop and disseminate the interdisciplinary principles and practices that enable systems engineering. Now there are more than over 18,000 members in over 30 countries. And I like the definition that INCOSE is giving to the concept or discipline of systems engineering, because aside from the typical interdisciplinary approach to enable successful systems and so on and so forth, it reinforces the idea, as you can see here below, reinforces the idea of having the customer needs and functionality of the system early in the development cycle, documenting requirements and the design and so on and so forth. So requirements are explicitly stated in the main definition of what systems engineering is. And I can say that I could not agree more. So this is the topic of today, requirements and requirements quality. A requirement statement is the result of a formal transformation of one or more needs or parent requirements into an agreed to obligation for an entity to perform some function or possess some quality. This is the formal definition of what a requirement is according to INCOSE, and then it comes out the definition of what is it of these requirements as a textual form that are not useful, but they are also necessary. That means that even if everything seems to be moving towards model-based systems engineering and diagramming and modeling, however, textual requirements are still needed to describe operational scenarios or for the verification of your systems, for the certification of the systems, and also if you think of requirements like part of a contract with suppliers, normally what we provide to our suppliers are not the diagrams, but are text contracts written in natural English or Spanish or whatever language, in natural language, and of course within these contracts you can find requirements. So it is very important to take care of the quality of these requirements. And mainly, if we go now to the left of this of the screen, if we think of the possible number of mistakes that we normally commit in our projects, according to this survey, it is up to 70% of these mistakes are introduced in the life cycle in this requirements phase, along all these requirements-related activities, but mainly the definition of the requirements, of course, also the management of the requirements. So 70% of these mistakes are introduced in the project in this phase. However, and this is what is even worse, it is not until the testing phase where we realize, we find, and we fix these mistakes. And of course, as you all know, this is meaning a lot of money, because the sooner you fix, you detect and fix your mistakes, your issues, the cheaper it is going to be. So the bad news is that all these 70% of mistakes that we can introduce in this early phase, only 4% of these mistakes are actually identified and fixed during this early stage. So the aim of the INCOSE guide for writing requirements is somehow to minimize this number of mistakes and also providing an early detection of them. However, the guide is a lovely document. However, we need something else, and this something else could be coming together with an automatic tool. And this is what I'm going to present to you today: a tool mapping this INCOSE guide, so that first of all we can reduce, by providing help to the author of the requirement. We could somehow reduce this 70%. This figure of 70% can be reduced by helping the author. And since we are all humans and we make mistakes, we are prone to making mistakes. Then, of course, this even if we manage to lower this figure, probably we will not reach the level of 0. So the point is also to provide automatic tools for inspection, so that by following all these rules in the INCOSE guide, we can meet a point in between. So reducing the errors we make and increasing the errors we can detect in the early stage of your project. If we manage to meet whatever point in between the 70 and the 4%, then of course there is a clear benefit in terms of the overall quality of your project and in terms of money and time to market. And as I mentioned, all this boils down to textual requirements, and probably you could say, hey, why the hell? I don't need a tool to tell me how to write, because I already learned how to write when I was attending primary school. But the bad news is that natural language, which is, as I said at the beginning, is fully needed even in a model-based system in the world. But natural language is prone to ambiguity, especially when we mix together different disciplines, like for instance, engineering and cooking. And I don't know if you have ever suffered what happened to my colleague. He's an engineer, and his wife told him to put the pie in the oven at 120 degrees. Probably there is some sort of ambiguity in this statement, and he was initially very happy with the project, and the endeavor for this guy to start the oven, open the oven, and put the pie at the oven. But probably his wife was not so satisfied. This kind of mistakes due to ambiguity of the language can happen when we deal with different disciplines, but also within the same discipline. As these three engineers, she's speaking about pi. This other guy is understanding pi in this way, but seems to be okay. This other guy is a little bit more formal, and probably he's understanding pi in this way. And of course, my colleague, he's still understanding pi in like the pie in the oven. So let's try to address this topic of learning how to write technical documents and mainly requirements and needs. And hopefully we have this INCOSE guide to teach us how to write requirements. This guide has been released by the INCOSE Requirements Working Group, and in line with its goal of expanding and promoting the body of knowledge of requirements engineering and its benefit within the systems engineering community. They have developed the latest version of the guide was released in 2019 during the past INCOSE symposium. And this guide provides guidance on how to express textual requirements. So the guide draws advice into a single comprehensive set of characteristics, rules, and attributes for well-formed needs and requirements. So this is kind of the main structure of the guide. The main chapters are describing first a number of high-level, but at the same time very nice to have quality characteristics. In this version, there are 9 characteristics for individual requirements, the ones described also in the ISO 29148, plus 5 other characteristics for sets of requirements, let's say for documents or for sets of documents. All these characteristics, as I said, are addressing the topic of quality requirements. However, they are a little bit too abstract or too high level, something like necessity, or if the requirement is appropriate to level, or if it is unambiguous, if it is complete, singular, feasible. This is all nice to have, but as I said, a little bit high level. So the good news is that together with these 14 characteristics, there are 41 rules, provided that each of these rules is addressing one of the characteristics, and at the same time, each of these rules is specific and measurable. So it's something that you can open your requirements document, you can open the guide, and you can have this guide like a kind of a checklist, and one by one, you can just tick whether or not you are meeting this rule. And finally, together with this list of rules, we can also find a list of attributes that are coming together with the textual statement of the requirement. So, as the topic of this webinar is how we have implemented this guide into actual, the way we have done it is by means of knowledge library. So let me introduce you, first of all, with some few slides, what is the concept of what is an ontology in our approach, and what is a knowledge library. So first of all, you can find a lot of different definitions of what an ontology is. And I will never claim that this definition is the best definition ever for an ontology. In fact, it is not. Probably it is not covering what especially formal guys will understand out of an ontology. However, our ontology has a special aim of addressing understanding natural language. So, and not only representing knowledge, which are not exactly the same goal. So this is why we have developed this definition of ontology into 5 layers. Let me just give you an example of these 5 layers, starting with a vocabulary, a list of concepts that could be either the basic concepts of a language, like small words like shall, the, of, determiners, pronouns, articles, and so on and so forth. then other nouns, but common nouns like system, to operate, to temperature, environment, pressure, whatever. And by the way, if you allow me to draw this vertical line here, because it is important to highlight the difference between what we call common English. And by the way, what is to the right, this common English is what you will find in our database out of the box. And also, when I say common English, I can also mean all the different languages that we include in our tool. Today is English, Spanish, French, German, Swedish, Dutch, Japanese, and I don't know if I am missing, and Italian, sorry, Italian. Right, so we have ontologies in these 8 different languages. And what is coming to the left is what is domain specific. And of course, is not, you cannot expect this domain specific part to be part of the library, of the out-of-the-box database. However, we are developing different dictionaries for different disciplines, like the space discipline or the automotive discipline. All these are all the libraries that you can find in our website. So going back to the idea of the 5 layers, the first one is to identify vocabulary. We have to understand what is the meaning of a requirement statement, and this statement will be formed of different words and concepts described. So we need to tackle this. Also, in our approach, we like to put these concepts together, either by relating these concepts by different types of relationships, or by grouping these concepts according to the nature of the concept or according to the meaning of the actions, for instance. Then it comes, then it comes the idea of textual pattern, which you can understand kind of like the structure of the sentence, so that a statement, a requirement like this can be fitting into this template pattern, providing us with this formalization. And this is what the tool will take to make some reasoning and determining, according to this rule that I was introducing in the second layer of the ontology, to mention that the temperature of my system has to be between 70 below and 70 above. And since I am mentioning here something like minus 70, then this requirement is out of the limit and is not considered like a good requirement, right? So this was very quickly the definition of what's an ontology. By the way, you have a lot of webinars in our website if you want to learn more about what is inside of actually inside of the an ontology. And now the definition of library. Library is a selection, a combination of knowledge items at any of these 5 levels, so that we pack this into the concept of library, and this library can be imported even in your own databases, right? Even if you have already worked with our tools and you have already developed your dictionaries or your rules, you can import this library that I will be presenting today, and all the content of this library will be added to the content, to the current content of your library. So the idea of a library allows us to promote the principle of quality right the first time, enabling semantic search portals to archive and retrieve assets, providing tools to reuse these kind of assets, reducing time to market, improving the way engineers generate or author new assets, enhancing the way these items are verified, and enabling a real interoperability so that we can reduce time to elaborate documents and system projects. So this is the overall idea of the different libraries that we have released. And of course, the one today is more focused on quality and the idea of quality right the first time. This is why I put this as the first item in the list. So all the libraries that we have developed and are fully available in our website for free. Remember that all of our libraries can be downloaded for free from our website. So I start with this, INCOSE Guide for Data Requirements. It is already available in our website. However, we are developing the interpretation of this latest version. Then we have other libraries like EARS, Easy Approach for Requirement Syntax, or Master Patterns that are including just patterns. There is nothing, for instance, in ears, there is nothing about quality rules or vocabularies, just patterns, while in the INCOSE one, you cannot find a large number of patterns. You cannot expect patterns in here, but you can combine together the INCOSE library with the ears library or with the master patterns library, and then you will have everything together. For instance, the patterns in the master, that was the topic of our latest webinar last month. You can combine this with the quality rules, right? We have all the libraries, including not only vocabulary or quality rules, sorry, but also vocabulary in terms of glossaries, dictionaries, and patterns and quality rules, like our library mapping the NASA Systems Engineering Handbook. This library is not fully ready, but we are working on it, and probably will be the topic of a webinar very soon, next month, probably, or the coming one. And we have also, even if it is not mentioned here, sorry, we have another library for the European Space Agency and the ECSS set of standards. This is fully ready and available for you. And we are also working on libraries for the ISO 26262. So let me introduce you a little bit the tools by which we have implemented all these quality rules. So this is the Systems Engineering Suite. I will not mention this the tool here, the one in purple. I will focus on the other three. We're starting with the RQA, Requirements Quality Analyzer, or Quality Studio. This is the tool we use to set up the set of rules that we want to implement. For instance, in this case, I have been using RQA to map all the rules in the INCOSE guide into what we call metric. So when it comes that these rules in the guide are transformed into a tool, we like to call it a metric. So in RQA is where you can manage the metric, and you can have RQA connected to different requirements management tools in, that act as the real requirements repository. This means that the RQA is not capable of managing requirements, right? We have to rely on external requirements repository, so that in the first scenario is kind of I create my rules, I set up my rules, I assign the different set of rules to the different documents, and then when I can open my requirements management tool to write down my requirements, and then when I go back to RQA, RQA connects to the requirements repository, retrieves all the requirements, analyze the quality, and shows you quality reports, and is capable of storing the quality results back in the requirements repository. However, this is just the first scenario. The second scenario is involving now the second tool, the rich authoring tool. All these tools are around the same database, so the information you provide in the three tools is shared in our system knowledge repository. So that the RAT tool, unlike the RQA, is an actual plugin on top of the requirements management tool. So when you open DOS or PTC or Excel or Teamcenter, you can find the RAT plugin on top, so that when you write requirements in this tool, the requirement that you write is analyzed in real time using the quality rules that has been established in the RQA, right? And finally, we have the Knowledge Manager. This is the tool we use to develop vocabularies to create the patterns, and also, if needed, to connect to external repositories where you can manage your knowledge. So that Knowledge Manager can manage natively information that is offered to the author of the requirement, or can connect in real time to tools like Capella or Rhapsody or Simulink or Cameo, Magic Draw, or even external ontologies in Protege, and retrieve the information in real time, as I said, and offer this information to the author of the requirement. So that if I was using, for instance, PTC Integrity or whatever other tool to write my requirements, I can create a new requirement that is automatically and in real time check against the rules that I have defined in RQA. I can create requirements following the patterns that I have created and in KM, and I can write these requirements using the concepts that are being retrieved from my models, and I can check the consistency between my requirement and my model, all this in real time using the requirements or the rich authoring tool. So this is the set of tools that we have implemented. So you can find more details about these rules in these slides, but I skipped this. And let me just go to the mapping. So the mapping, this document is the mapping we have done between the rules in the 41 rules in the guide and a number of different metrics. We have so far in this version come out with 57 metrics mapping. Unfortunately, not mapping the 41 rules. We cannot address some of the rules in the guide, some related to feasibility or some related to the structure of the document in terms of the sections and so on. We cannot tackle these metrics. However, I'm happy to announce that we have only I don't know if you can see it here in red, 4 nodes in this mapping table, right? This mapping table can be downloaded from this link, so you can take the PDF. You will soon receive a copy of this PDF, the PDF version of the presentation, so that you can download the mapping, right? So in this mapping, you can, as I mentioned, there are more metrics than rules. And what does it mean? The idea is that for some of the rules, we have only one metric. So for instance, for the correct spelling, we have only one the metric of detecting incorrect spelling. However, for other metrics, we have what we call a progressive set of rules, meaning that we offer you 2 rules so that you can, if you wish, you can start with the first one, with the first of the rules, and then after a while, you can decide to start using the second rule, which is a kind of more advanced rule, right? So for instance, in the particular case of the active voice, you can have just a basic checking, or you can detect passive voice, but not in the condition, and only in the action. For instance, you can change between these 2. And then we have also other metrics that we have implemented by a combination of different metrics. So, for instance, the rule of vague terms, which is just one single rule, has been implemented in our approach by a combination of 1, 2, 3, 4 different rules to avoid vague verbs according to the level of abstraction of my document, avoid vague adjectives, speculative sentences, vague adverbs, and so on and so forth, right? So this is just another example. We have come out with all these number of metrics. Most of the metrics in that we have created mapping the rules in the INCOSE guide are what we call metrics based on correctness. We like to classify all these metrics in 3 different dimensions. First of all, the idea of correctness for the quality of individual requirements, while also the metrics based on consistency and completeness for the quality of sets of requirements, or even sets of documents. All these, as I said, in this library are implementing the quality rules. However, in the INCOSE guide, however, we always like to mention our customers, please take this guide carefully, because probably this could be too much for an unmature team, and tailoring is key. Especially, you can find requirements teams with different levels of skills. You can also analyze requirements at different levels of abstraction, or at different stages in the project, or requirements for the quality rules that you could be aiming to analyze for a very safety critical component of your system. Probably is not the same level of strictness that you will apply for the requirements of another component that is not so critical. So all this makes that even if you will find when you download our library, you find a set of rules, but we have classified this set of rules in an increasing level of strictness, if I can call it in this way, right? So these are just examples of rules in the 3 dimensions, starting with correctness. So we have, as I said, implemented rules to detect forbidden keywords, or keywords that you can analyze in different ways, right? And also the idea of checking conformance between our textual requirements and our models as well, right? So all this I will try to describe during my demo, and some screenshots, some details about this, right? And also, as I mentioned, metrics based on the idea of patterns. For us, patterns are key, and you will see during my presentation and during the demo, you will see patterns in action, so that you can understand what is the powerful of a pattern. And of course, you can just check our website, and we have released a number of different webinars on the topic of patterns, and you can find the recording to all these webinars. So the second dimension, completeness, to me is the most challenging one, even for humans, to know when you are done. And one requirement more could be that you are duplicating something, or you are going beyond the scope of the project, or you are over specifying one of your requirements. And one less could be meaning that you are missing something. So it is very complicated for a human, and it is also complicated for a computer. So you cannot expect our tools telling you, hey, you are not done yet, or you are fully complete, let's say. But what we can do is we have identified lacks or gaps in our specification, which is not the same. So, for instance, what we do to check completeness is when you manage to connect the requirements with a set of models in this MBC discipline, then we can, for instance, if I go back to this idea of kind of PBS, we can identify, for instance, that if this is your PBS and there is no requirement including, for instance, the video card as the subject of the requirement, so something like the video card shall, whatever, then probably you are missing something in your specification. Or if together with this PBS, product breakdown structure, you provide a state chart telling us that the computer can be in normal state, or in hibernated state, or in low battery state, and you don't find any single requirement saying something like when the computer is in low battery state, then I don't know, the monitor has to shall reduce the brightness in 10%. If you miss requirements in this way, is that you are not addressing this state, and probably this means that you are missing something. So this is the way we tackle the difficult discipline of completeness. Completeness for sets of requirements, but also it is a little bit more, it's a little bit easier, as described in the INCOSE guide, completeness at requirement level, so that by following the full structure of a pattern, as is well explained in the guide, then we guarantee that this requirement is complete itself, or some requirements will be, or some units in some requirements will be forced to come with a tolerance. If you are missing the tolerance, then your statement is not complete. So you have a lot more information about what completeness is in this webinar. This picture here below includes a link to a previous webinar I was presenting a year ago, so that you can find more details on this. Then consistency, I will try to show you some consistency examples during my demo, but it's something like avoiding or checking, detecting consistency between requirements, or consistency between requirements and models, or if you link your document with some signals in a physical modeling tool, and you have the possible values of the signals, we can identify that the values you are mentioning in your requirement are out of the limits that you are mentioning in the definition of signals in your models. Or if you are mentioning a transition of a state which is not consistent with the information you have in the state chart, then all this is problems in consistency. Again, you have more information in this other webinar presented by one of my colleagues last year, so you can follow this link if you want to know more about consistency. And then the idea of patterns. For us, patterns are key for many different ideas, mainly to help authors writing requirements following the patterns, but also mainly that patterns that allows us to detect what is the actual structure of the requirement, so that we can contextualize some of the metrics according to in which position of the requirement we are speaking. So, for instance, and by the way, if you want to learn more about patterns, you can this webinar that I am pointing here on the left is mentioning what a pattern is, and this is the webinar we produced last month, describing a specific set of patterns, the SOFIS patterns, right? So patterns allows us to do something like, as I said, contextualize some of the rules. So these two boxes are describing two rules in the INCOSE guide, rule number 2 and rule number 19. This is detection of active voice or passive voice, let's say, and this is the detection of combinators. The idea is that the definition of these two rules in the guide, according to the guide, is giving you, okay, use active voice, but you have, in both cases, you have some exceptions, let's say. So in here, it is only telling you in the main sentence structure, right? And in here, you can find something like and, or, and not can be used in need and requirements statement as logical conditions. So a logical condition is an exception to the detection of and or. So the idea for our tool is not only to detect and or not, or it's not only to detect a condition, passive voice is also to detect that this passive voice, for instance, is coming with the condition. So something like when, I don't know, when sensor A is activated, technically speaking, this is a passive voice, but this passive voice is not harmful. However, if I follow with something like, and whatever has to be released, who is in charge of releasing this? I'm missing the subject, and has to be released or shall be released is passive voice. And this is a harmful passive voice because it is missing the subject, right? So with the help of the pattern, we can contextualize and a connector or combinator or a passive voice in the condition can be just simple. The tool can say, okay, this is okay, while if it is happening in the action, it is not okay, right? This is just an example of this. So you have passive voice here and there, but the tool is just checking or identifying one issue, and this issue, of course, is the one which is in red here, right? Similarly, we apply semantic technique to the analysis of our requirements all over the requirement. So for instance, in this requirement, the rotor shall turn around the core at a minimal speed of around 70 revolutions per minute. The word around appears twice here, as you can see. And I took this online part of speech tagging tool so that you can see like around appears twice. This one, it appears in white, and this one appears in brown, meaning clearly that the role of this around in the sentence is different, right? While this one is fully necessary, this one is making my requirement ambiguous, right? And this is what you can find in the tool. So when you analyze this and the very same requirement with the tool, then you find that there are two around, but the tool only detects one issue, and the issue that is detected is exactly this one, which is making my requirement difficult to be measured and verified, right? So this is just a large screen of the mapping, and my last slide is just to mention the idea of the smooth implementation of the quality rules, and this is why in our library you will find not only a set of rules, but you will find 3 different subsets of rules so that you can apply this subset of rules in a progressive way, right? So we like to call it something like in martial arts, white belt, starting with white belt, yellow belt, orange belt. So this is the way we have implemented. So for instance, in the white belt, we have implemented just some correctness analysis using just syntax analysis and a little bit of control vocabulary, but just a little bit, and probably nothing about patterns. While in this second step, yellow belt, we start using some patterns and a little bit more about correctness. And then in the orange belt, then we jump into formalization of patterns and relationships in the ontologies so that we can tackle the idea of completeness and consistency and so on and so forth. So this is the idea of how we have implemented our all of these metrics. So now I jump into a demo. In this demo, I will be showing you RQA. RQA in this time connecting to requirements repository. We can connect to different repositories, but I will choose those in this case, right? So when the tool connects to the requirements repository, it shows you the different documents. I will be selecting just one document for this demo. I can check several if I wish. So since I have already analyzed the quality of this document, then as soon as I open, I can find 1, 2, 3 stars, low quality, medium quality, low quality for correctness, and also the number of issues that has been identified for consistency. I can sort, I can filter according to these criteria, and I can just move the mouse over the stars, and then I will see the recommendations why this requirement is considered as low quality, high quality, and so on, right? Then I go to the definition of the quality rules, and this is what I was mentioning: 3 different levels: white belt, yellow belt, and orange belt. So I open one of the belts, and then I can see 48 rules. There are in fact 53, but I just show the ones that are enabled. So for each of the rule, you can metric, by the way, because this is the implementation of the rule. For each of the metric, you can see our name, and you can see what we call the quality function. The quality function is the transformation of the value which is retrieved from each rule into a quantitative value. So for instance, the passive voice has a very simple quality function of no passive voice is okay, 1 or more passive voice is not okay. But for instance, the text length, the quality function is a little bit more complicated, let's say, meaning that a word, which a statement which is too short and less than 4 words cannot be a requirement. But if it is between 4 to 35 words, it can be a requirement. But if it is larger than this, it is starting to be a little bit too much and probably a poor quality requirement because it is too large, as I said, right? So from here, you can create more metrics. You can instantiate metrics. So the number of metrics that you can implement is very large, right? So once you have come out with your definition of your metrics, then you can apply different combination of metrics to the different documents. So in this case, I will be applying orange belt to the document I want to analyze. Okay. And then in the configuration, I can do things like filtering or deciding if I want to save the quality back in the requirements management system, or as I said, filtering in order not to analyze headings or rationale statements and only focus on quality on requirements statements. So I go back to the main screen of the tool. And I can reanalyze again. As you can see, it is very quick. It's a small document, only 75 requirements, but it takes only some few seconds. In fact, most of the time is devoted to save the results back indoors, in this case. So I'm done with the analysis, and you can see again the stars here, right? So I can, from here, I can open reports, I can do charting, I can see the quality evolution of my requirements. I can do plenty of different things from here. This is, by the way, this is the tool aimed to be used by the quality guys, not by the author of the requirement. But even from here, if I wish, I can filter. I can find a requirement, for instance, and the tool is telling me in this particular case that this requirement is using can, while I was following the INCOSE guide and some of the guides just to tell me that I wanted to use shall, will, should, but not can. So this is why the tool is complaining. And as soon as you open, then you can see something like the tool is missing the shall, and you can of course fix this issue. And if you want from here, you can save back indoors if you wish, right? So let me move forward to show you other metrics in the implementation. So for instance, now in this particular case, I will try to identify which requirements are not following the appropriate grammar. So I have created a set of what we call anti-patterns to identify requirements that are written in a weird way, like there shall be something. So I normally don't like this idea of there shall be. So just by creating structures for the patterns that you don't want to find in your requirements, then you can have the tool identifying, in this case, 3 requirements following this structure of there shall be, so that you can fix these issues. Then now let me speak a little bit about rule number 2 and the detection of passive voice. In this case, I open this requirement to show you that technically speaking, there is a passive voice here. So the system is activated, as I was mentioning before, is technically speaking is passive voice, but the tool is telling you that this requirement is okay. This green frame, by the way, is telling you that the requirement is okay, just due to the fact that the tool identifies that this passive voice is coming with the condition and not with with the main action. However, if I now open this other requirement, then you can see like the tool is telling me that there is one passive voice shall be designed. Of course, this is a harmful passive voice. However, the doors are closed and the train is stopped. It's also passive voice, but again, passive voice in the condition that is not harmful, so the tool is not will not detect this. By the way, if you are not happy with this interpretation of this rule, and you want the tool to check every single passive voice in the requirement, whatever it happens, then of course you just change the configuration. It takes 1 second to change this configuration and detect all the possible passive voice. I move forward a little bit to rule number 5, which is kind of the definition or the use of the indefinite articles in your requirement, so that in this case, and is an indefinite article, but it is not coming in front of an entity. It is describing an availability, which is not an entity, it's a property. So this is why the tool is telling me that this requirement is okay. However, if I enter in other requirements, oh, sorry, by the way, if I go back a little bit to this one, not only this, the second issue here is with the number 100%. Normally, the numbers has to be coming followed by a measurement unit or an entity. In this case, 100% is a number, but it is an absolute number, so it is not detected in this metric, right? However, if I open other requirements using numbers, then I can find like the tool is complaining and saying, okay, the temperature of equals 40 watts, something is missing. So the tool detects that there are some units that are missing. So I can do a lot of things with numbers and units. So for instance, I can, after the 40, I can provide a unit. So in this case, degrees centigrade, and the tool tells me, oh, it seems to be okay, but I'm missing the tolerance. Equal 40, you miss the tolerance. By the way, if I make a mistake in the detection of the unit, and I say 40 kilometers, now the tool is telling me detect inadequate unit for a specific characteristic. So the temperature is not measured with kilometers. So I go back and again, I say something like degrees centigrades. Again, the tool is telling me, oh, I'm missing the tolerance. So I can go and deal with the tolerance. So I click there. I write my tolerance, plus minus. And then I provide the value for my tolerance, but I say plus minus 1 centigrade. This is making a tolerance of only 2%. I have established limits for my tolerance. If the tolerance is too small, then probably it is not feasible to have such a small tolerance, because a very small tolerance is like having no tolerance at all. So 1 centigrade is too little. While if I say something like 42, it is making now this time the ratio between the tolerance and the nominal is 55%, and probably this is too much according to my configuration. By the way, you can change your configuration when you wish. So in this case, I change the tolerance into something which is the 10% of the nominal, and then the tool is going to tell me that this is okay. So now in a second you have the 3-star here, or let's say the green frame. So I move forward a little bit this topic just to show you that different configuration of your requirements, something like is between 40 and 50 Celsius. There is no tolerance in these values, but it is a range, so the tool can detect that it is a range, so there is no need to have a tolerance. So all this can be configured in the way you wish. So I keep moving. This is the idea of a round that I already mentioned. So I skip this. Then I just go to the idea of detecting negative particles. It is important to mention that this, according to the INCOSE guide, there is a lot of exceptions in the rule in the method to identify negations. So first of all, as I was mentioning with the idea with the rule based on connectors, we can tell the tool with this block here. If you follow my mouse in the screen, we can make the tool not to analyze the condition when detecting passive voice. And in here, the following block, the following way you can filter somehow or prevent somehow this rule to be analyzed or to be analyzed in a particular way, could be in here, right? So you can establish a filter so that this rule is not applicable, for instance, when is not applicable, if I go back a little bit, this rule is not applicable when the type of my requirement is a safety requirement. So it is now this configuration makes that requirements that are safety requirements will not be applied in this rule, and the rule will be applied for the rest of the requirements, but not in the condition, but only in the main clause. Of course, you can implement an additional rule just to say that even in a safety requirement, you can use a negation, but one and only one, and not more than one. So all this can be done with the different easy configurations for the of the rules, right? And this configuration, as you can see, it is very easy to come out with more rules, less rules, configure in different ways. There's no need to do coding or whatever. It is as simple as just editing these screens, right? So this is just one more rule. In this case, it is consistency rule, telling me that I am mixing up requirements with inches, or measuring length in inches, and requirements measuring length in centimeters. So normally this is not welcome, so the tool can also identify this point. More about the grammar of my requirements, use of pronouns, so a lot of different methods that you can implement. So now let me, this is the RQA, the tool for the quality people. Now let me finish the demo with the tool for the author of the requirement, having real-time quality checking. So this is now RAT, the tool for the authors. So I log into my requirements management system. I open my document. And then as soon as you open your document, you can see a RAT or authoring menu here on the top. This authoring menu is the menu created by the rich authoring tool, the RAT tool, allowing you to create new requirements or to edit requirements even within your requirements management repository, or even to create what we call a quality view. A quality view is a set of attributes and columns, including the information that has been created a minute ago with the RQA. So you can not find here 1, 2, 3 stars, but you can find low in red and medium in yellow and high in green. So it is meaning the same as 1, 2, 3 stars. And what is more important, what has been the findings of the requirement. So each of the issues that has been detected in RQA are now shown in this screen, right? So what can I do in here? I can, for instance, write a requirement not using the RAT. So the train should be designed to be very fast. And as soon as I finish the edition of my requirement, there is a trigger telling me that the quality of this requirement is low because it is using passive voice, it is using vague adverbs like fast, or it is using a superfluous infinitive like to be designed to, or it is using an unprecise quantifier like very. So I can now edit with a shortcut. I can now edit with the RAT, and the tool will be showing me this frame in red and all these 4 issues in the list, so that as soon as I can just click in the passive voice, the tool detects the passive voice. If I click on the vague adverb, the tool highlights fast and tell me avoid vague words like fast. They make the requirements difficult to be verified. Use a specific speed instead, right? So this is the piece of advice that the tool is giving me to enhance the quality of my requirement. And the same for the other issues that has been detected. So now, of course, I am on top of the requirements management system. So similar to the possibility of fixing in real time with the RAT and saving, the RQA offers you this possibility, of course, but it's mainly the RAT that allows me, for instance, to start with a requirement from scratch. In this case, even an empty requirement is considered as poor quality because there is no shall, it is not following the structure, there is no action, it is too short, and so on and so forth. So now, as soon as I start typing, you can see, like in real time, the number of issues is being reduced as I start typing, and the speed of the train shall be 300. If I say just 300, the tool again tells me that 300 what? If I write something like kilometers, then kilometers is not a unit for speed. So the tool is telling me so. And if I say kilometers per hour, now everything is green. So now everything is high quality. Of course, I click and save, and the value in the quality view changes into high quality, and there's no actions to be taken, so the summary is empty, right? I can create a new requirement, let's say from scratch, using the RAT tool. And in this case, I have selected one pattern to write my requirements. So the patterns are offered for you. First, you pick the type of requirement, system functionality, and then the requirement, state transition. So you can see the structure, and you can see like when you start typing, the tool is suggesting you the possible words, let's say for the following step. So when, the, and then these drop-down lists are showing you what is the following step, so that the writing is easy, quick, and consistent with the vocabulary and with the rest of the requirements in your specification. So this list, by the way, is the list of possible states according to my dictionary or according to my models. So the GPS system, when the GPS system is in emergency state, and now it comes an open section of the pattern. It's like a free typing. So now from this point on, I can write whatever I wish. So it's free typing for the condition, at least in this stage. And normally we implement full patterns, not in the first stages of or not in the first belts, but just when we advance a little bit. So now, as I said, it is free typing. I can write whatever. But as soon as I get to the delimiter of my condition, so and I type another name of a system, or something like the GPS system shall. This is the delimiter. So now is when the pattern gets again back to offer me elements. So shall transit into, and again the list of possible states, into the activated state. So now you can see this frame, this green frame, telling you that this requirement is following the structure, right, of the pattern, and the quality. Well, there are some issues in the pattern. So first of all, according to my ontology, there is no such emergency state for the GPS. This is something that you can see here. The GPS cannot be in emergency state. So this is what the tool is complaining here, and similarly. The transition, since the GPS system cannot be in emergency state, the transition between emergency and deactivated is not a valid transition. So these are the two issues that are highlighted here, and this is why the quality of this requirement is not green, even if it is following the structure. So all this is what you can expect of the RAT tool, right? And then my final requirement, also following a pattern. In this case, is another pattern to express a physical property. So I write the weight of now the list of elements in my PBS. So the weight of I pick one element, the weight of the train shall be, then a number shall be 400,000 pounds, right? So everything seems to be okay about correctness. So the correctness frame is okay. And the pattern, this green frame is meaning correctness, and this other frame is meaning that the pattern is meeting the requirement is meeting, is conformed with the pattern. However, we can also implement real-time consistency checking, so that if I now go to do the checking, consistency checking is not analyzed as correctness at every keystroke, mainly because consistency can take longer to be analyzed. So I can, but I can force from here. It takes only just a few seconds because the document is very small. So the tool now tells me that this value for 100,000 pounds is making something like 198 tons. The tool can make this transformation in a very quick and easy way. And according to the definition of what a train is in my ontology, I have established some limits and values telling me that the limit has to be between 500 tons to 600 tons. Of course, this value is not enough to get into this limit. So that if now edit my requirement and then I change into kilograms, just to avoid the issue with the measurement units, by the way, and I put this in the limit between 5 to 600, then now I can repeat the assessment. And hopefully I will find that this red tick turns into green. Okay, now it is green. So telling me that the quality of this requirement is okay. And that's all. This is the end of the demo, and this is the end of my presentation. So please, Cecilia, if you can continue.
Thank you very much, Jose. If anyone has comments or questions, you can send them through the chat box to the youth company or to everyone. We already have a couple of questions, but I will give you some to write down more questions. And meanwhile, I will tell you about our next webinar. It's called The Financial Cost of Bad Quality Requirements, a surprising discovery using the Cartesian model. The dates for this webinar are the 15th and 16th April. In this webinar, we will run a development project using requirements with a high versus low degree of requirements understanding, and what the economic benefits would be when using the INCOSE guide or writing requirements for real with our state-of-the-art systems engineering suite, offering you the tools, processes, and skills to properly tackle the daily issues of complex systems. This with the benefits of increased quality, save development effort, and money. So let's go to the questions. Change requirements directly in the tool, and are they synchronized to the requirements tool? How connection realized?
Sorry, I was mute. Yes, this question, I think that it refers to the tool RQA, because the tool RAT, the RAT is an add-on on top of the requirements management tool. So for the RQA, yes, as soon as you save in RQA, this change is synchronized. And the question is how the connection is realized. It depends on the tool. So in terms of doors, we use DXL to communicate with doors. And in terms of, for instance, PTC integrity, we use the PTC API to connect to the server and store back the updated version of the requirement. So it is the connection is done depending on the tool we connect to, using APIs or using specific languages like DXL.
Okay. Does the orange belt include the lower belts when you check your set of requirements, or is each belt independent from the others?
Normally, in our incremental approach, one belt is developed on top of the previous, so that if let's put it simple, if yellow belt includes 20 metrics. Then orange belt includes the 20 metrics in the yellow plus a number of other metrics, or it can be that one metric in the previous belt is more strict. So a clear example of that is, for instance, the text length. At the beginning, I can allow. Normally, the issue with the text length is that normally our requirements are too large, so that in the white belt I can say, okay, I accept something like until 50 words long. Right? While in the yellow, I say, okay, now in the yellow only accept 40, and now in the orange I only accept 30. So you can go progressively. You can be more and more constrained in the way of writing. So two mechanisms. One, as you said, one belt is on top of the previous one, including all the previous metrics, and it could be that also some of these previous metrics is a little bit more strict.
Okay. Is there a complete list of integrations to requirements management tools?
I think I don't remember by heart. I think in our website you can find a complete list of integrations. But if not, Cecilia, we can provide it when we provide also the recording and the PDF of the slides. We can also give you one PDF, first of all, by the way, with the set of rules that we have implemented, and also a small table showing the integrations we have done for different purposes, by the way, because some we have integrated with some tools to retrieve requirements, or with some other tools to retrieve information from models to be used for the quality of the requirements. And in some of these tools, for instance, in Rhapsody or Capella, we can do both. We can We can analyze the quality of requirements in Rhapsody or Capella, and at the same time, we can use the information from the models to check the quality of the requirements. So we will give you a complete table with this integration.
Okay, thank you. We don't have any more questions, so thank you very much for attending. If you have further questions later or want to receive more information, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you very much and goodbye.
Thank you. Thank you. Have a good day.